Hi. My name is Matti. I'm a full-time NumPy developer. How many people here use NumPy? Very good. That's about what I expected. How many people have a GitHub login or GitHub username and use GitHub? Okay, how many people have registered an issue on GitHub in an open source package? An issue. Well, that's pretty good. It's about a third. And how many people have done a pull request? We got about the same number. That's good. And how many people have put an issue into NumPy, Python, SciPy, the scientific stack? Nobody. Oh, one. Good. All right. So I'm here to do three things this evening in something like 20 minutes, I hope. One is to entertain you a bit. One is to convince you that open source is something that you can do, that it's not that scary, that it's something you can become passionate about. And the third is to a little bit talk about where we're going with NumPy and what we hope the future will bring for NumPy. So I'm going to talk about my personal story, how I got involved in open source. Here we go. My first steps with open, so I moved to Israel in 1982 and I started a kibbutz down south, Kibbutz Lotan. Anyone ever heard of it? It's in the Arava? Yeah, so good. It was a great place. I spent about 10 years there, and then in 1993 I started doing a PhD at the Technion. And I took over a laboratory in the Technion that I was in agriculture engineering, coming out of a kibbutz. You know, where should I go but agricultural engineering? And I took over a lab that we were doing some interfacing with C, with actual controllers, with hardware, and we had to do it in C code. And I was teaching undergrads how to use C and how to interface with this equipment. And we had a NetWare network that was supported by the Technion, but it didn't have internet access. And so the internet was just getting out in 1994. It was becoming really popular. So I took the server and I converted it into Slackware. That was my first steps with open source. I downloaded stuff from the nascent internet and started compiling it. And I also did my doctorate in MATLAB. And I created something that called it an adaptive sorting toolbox. And I thought it was really cool and that other people should be able to use it. And so people use MATLAB. How many people still use MATLAB? Good. It's a great program. It's okay. It's all right. Don't be ashamed. It's all right. You should move to Python, but there are things that Python does that MATLAB can't. That MATLAB does that Python can't do, and so keep using it. It's a great program. In return for giving MATLAB my adaptive sorting toolbox, what happened was I tried to upload it to what's their sharing platform called? They have some MATLAB Central. Very good. Someone still remembers what it's called. They have this sharing site where you can download other people's MATLAB toolboxes. I thought I'd upload it to there. I asked them how I upload it. They said, well, hang on a minute. That's a pretty interesting toolbox you've got there. Sell it to us. I said, okay, I want a lifetime license for MATLAB. And so I have a lifetime license for MATLAB 4. Anybody who wants to use it is more than welcome. And those were my first steps with open source. Okay, not very successful, those first steps. And then I plunged into a whole different world, the world of C++, real men, you know. We're doing C++. We're not even like, women don't even like get close, right? This was in the ages of when men were men. Visual Studio, doing image processing. I wrote whole test harnesses in C++, and we even wrote CGI scripts, executables that ran on the server in C. Compiled them, loaded them up to the server, ran them under Apache. It was a different world. But then I saw the light. I discovered Python in about 2003 or 2006 and started writing my tests in Python. That was the first thing I did. And I discovered that you really don't have to write everything alone. You know, you can use other people's stuff. We're using NumPy and OpenCV to work with 2D matrices. And my GitHub, I joined in 2011. And my first contributions were to an Arduino Ethernet shield. I had an issue there with the way the Ethernet was working and tried to fix it for them. And then I found myself not really fully employed. I had a little free time in the evening when I could play around with stuff, and I was looking for a hard problem. And I found PyPy. Anybody know what PyPy is? PyPy? All right, good. You use it in production? No. Played with it? Good. All right, so I found PyPy, and I found this demo that they did. Found this PyPy status blog, and what they did was they started, PyPy is an alternative Python implementation. Okay, CPython is written in C. PyPy is written in Python. It has a JIT. It has a just-in-time compiler. So you run your code in it, and it thinks about your code, and through the 1,000th time that you've run that code through the loop, it says, aha, that's a hot loop. I'm going to compile that down to assembler, turns it into assembler, and from then on it's running in assembler and not in Python. So they had this really cool demo they did where they got Sobol working. Can you see there? It's pretty small. Control-Shift+. Where CPython was doing this Sobol in about 1/10 of a frame a second, and PyPy was running it in 50 frames per second. They were taking a video from a webcam and doing a Sobol transformation. Mean anything to anybody? Sobol filter? Finding the outlines. Okay, good. There's some image processing people here. You are the same people who are contributing open source. You guys you're just like raising your hands, don't you? Okay. So they connected the webcam to this, and they were doing a Sobol transformation in real time on PyPy. I thought that was really cool. And then they had a call to action. They said, let's put NumPy into PyPy. So that became my Sudoku. Who does Sudoku here? What do you guys do in the evening when you're like bored? Fortnite? No? I don't know. You know, so like I used to do Sudoku when I'd like have a couple of hours spare. I'd spend some time just on the looking at Sudoku, and so I decided to try and do this instead. And so I really got involved in pushing commits to this repository of PyPy and helping write tests, and we did test-driven development and pushing NumPy into PyPy. And by November of 2011, I was hooked. Here's my open. This is do you guys know OpenHub? OpenHub is a great site if you're looking for quality of open source. You're trying to figure out how good open source package is. Go to OpenHub and look about it. And you can also look up people. That's me. And you can see my commit history on in all the packages I've contributed to. I've done over 3,000 commits in about 7 years. And you can see when I've been active, when I've been on vacation, doing some other things. So I really got hooked into this whole open source thing. Now let's get back to the story and moving on. So one thing led to another. I became very involved in the open source community. I started giving courses for scientific Python, helping people move from MATLAB to Python where it was appropriate. Helped set up in large organizations, help them set up tracking of open source packages, where they're using them, because they're people who actually produce a product that they're selling to someone. The people want to know what packages are inside those products. We needed license policies about what licenses were permitted and not permitted. And I started giving talks about open source. I gave a talk at PyCon Israel in 2016 about PyPy, and in PyCon Israel 2017 about CFFI, C-types, and Cython. The C-types you know about, right? CFFI, anybody know about? It's a way to wrap C code. You're the same people who use PyPy. You know everything. It's a way to wrap C in Python. And it's also very fast. And Cython, I hope people know about. If not, you should learn about it. And then in November, the Berkeley Institute for Data Science opened up a contract to hire 2 to 3 people to work full-time on NumPy. So since April, I've been working at the University of California in Berkeley. I'm working half there and half at home because I have a family. I'd like to be with my family. I like them still. And been working on NumPy. So that's how I got involved. I kind of got dragged in, not dragged in, but I kind of like got sucked in 2011 or so, 2012. And so over the past 5 or 6 years, I've been boosting up my open source contributions, become my passion, and finally found myself actually working on it and getting a salary for it. So what did I do in the summer when I was at NumPy working on, at the University of California in Berkeley? I was there for 3 months and I was working on NumPy. We now have a roadmap that I'm happy to talk about. We have what we call NumPy enhancement proposals, ways we're going to move NumPy forward. I gave a couple of talks at SciPy in Austin, Texas, and next week I'm going off to Italy to give a talk at Euro SciPy. What I can say about NumPy is that, so how is it? How is all this work? How am I doing? On time? Okay. Yeah, okay. So how is it being an open source contributor? Okay, first thing you've got to know, you've got to have thick skin. Okay, because your work is out there on the internet. You can't be ashamed to make very public mistakes. If you have like problems with ego and stuff like that, then you're going to have problems with open source. I myself put a bug into NumPy release 1.14.4 in June, and then we had to make a 1.14.5 because of that bug. It was a really small bug, but it was worth a new release. And a lot of my commits, if you go into PyPy and you look at their commit history, all the commit logs, you'll see a lot of typo, whoops, didn't work, back out this one, and that's all up there on the internet. I mean, if someone ever wants to employ me and they want to look at my commit history, they'll see all those commits. They'll see some really good commits too, but they'll see all the ones that either got rejected or that were pretty stupid in the first place. And you need a lot of patience. Open source moves very slowly. It's based on volunteers. You can put in an issue, like about a quarter or a third of you have done, and nothing will happen for a couple weeks, and then maybe someone will look at it. Or you can write a pull request. You can spend a weekend writing your pull request. Nothing will happen to it. You'll ask them what's going on. They'll say, yeah, we don't really have time to deal with this right now. So you need a lot of patience to work on open source. So I can talk a little bit about the roadmap of NumPy. I can talk a little bit about PyPy. What we did over the summer is we tried to define what we want NumPy to be and what we view as the scope of NumPy and what we view is going to be outside of the scope of NumPy. NumPy, as most of you know, is an in-memory, n-dimensional, homogeneously typed arrays on the CPU. Okay, so we view our mandate as people use NumPy in TensorFlow in Dask. Anybody use Dask? Yeah. Okay. Good. In lots of other situations, but that's actually not NumPy. Okay, Dask is a NumPy, what we call a duck array. It looks like what we call a homogeneously single-typed array on a CPU, but it's distributed across a number of computers. In TensorFlow, that single pointer is up on the GPU. It's not on the CPU. Okay, there's another package called CuPy that also does this. NumPy isn't going to do that. Okay, but what we are going to do is we're going to support all those other users of NumPy, and we're going to give them a higher level API so that they can write their stuff, we'll write our stuff, and the world will still be happy and we'll have one interface. You'll still do, say, import TensorFlow. From TensorFlow import ND array, you'll still get an ND array that you can do mean, sum, you can do all the things, linear algebra on it. It'll still work the same if you use NumPy's in-memory CPU array, or if you use TensorFlow's GPU array, or if you use Dask's distributed array. That's our hope. That's one of the big things we're working on. The other things that we're trying to work on in our roadmap is the D-types. People know what D-types are, right? So this in-memory homogeneously typed array, every piece in that array has a D-type. It's either an int32 or an int64 or an int8 or maybe you can actually define a struct if you want to get really complicated. So we want to make that whole system a lot easier to use, a lot easier to work with. We want it so that people can actually inherit from those D-types and make their own if they're going to be categorical, things like what Pandas does these days. Or they can be have units attached to those D-types. So if you have an int32, It might also be a foot or a meter or a mile. That's pretty much where we wanted to go with NumPy. And PyPy, for those of you who don't know about it, I had a slide up here, but PyPy is another implementation of Python. So in Python, when you probably download it from Anaconda, that's what most people do, you get an interpreter that's written in C. PyPy, you can download an interpreter that's actually written in Python, translated into C. And as I said, it has a JIT with it and a garbage collector that's a lot faster garbage collector. So if you want to write native Python code and have it run very fast, you should do it in PyPy. I think I'll stop here. Did I entertain? Yeah, okay. Did I convince you that you should try and do some open source? Maybe. Okay, and I hope I've given you some information about where NumPy is going to go. And I'm going to be here, like, we're going to take a break soon, right? No? Oh, yeah, but so people are, yeah, so I'm happy to entertain questions now, in the future. And Matti Pincus, my GitHub name is MATTIP. I'm on IRC. I'm one of the things that I view as my job as a full-time NumPy developer is to encourage people to get into this world, to get involved, make your first pull request, make your first issue, file some issues, make some pull requests, and get involved in the community. So it's no longer a world of just of old white men, you know, using C++. And so let's get everybody doing open source. Questions? Don't be scared. Yeah. Repeat the question. The MKL distribution of NumPy. Okay, how do we relate to it as open source developers? This is a commercial venture that's kind of making things work faster on their chips. We're very happy that people are using NumPy, and we view it as our mission. That people use Matplotlib, yeah. People use Bokeh. And the other Plotly and all those others, that world is starting to fragment. That world is starting to, like, there's all these other implementations of ways to do plotting in the Python world. That kind of scares us, okay, in the NumPy community. We don't want that to happen to NumPy. We don't want there to be a fracturing of the API, of the high-level API. We want people to be able to import something, whether it be Intel MKL NumPy or Dask or whatever, and be able to use those APIs consistently. So we have a good relationship. It's kind of annoying when we get bugs that are due to their compilers, but we work it out pretty quickly, and we help them work through their issues, and you know, it's all good. So they should be healthy and give us lots of money, and yeah. More questions? Yeah.
Regarding your position at
okay, so the question is, this whole Berkeley Institute of Data Science BIDS place, what's going on there? What's the story there?
Yeah.
So there's a couple of philanthropic organizations in the world, the Moore Foundation and I just blanked out on the other one. It'll come to me, that have given money to promote reproducible science. They view science as something that should belong to everyone. And at the end of the day, we're paying for it, right? We're the ones supporting, our taxes are going to supporting these scientists doing all this academic research, or at least our tuition or our taxes are going to it. And so all that science should be open, should be reproducible. So these foundations have given money to establish 3 institutes across the United States. One's in Berkeley, one's in University of Washington in Seattle, and one's in New York. They're called Institutes of Data Science. They all have their own little names and their niche things that are going on there. The Sloan Foundation, that's the other one. The Sloan Foundation, the Moore Foundation, gave a grant to NumPy through the Berkeley Institute for Data Science to hire a couple of people, me being one of them. Tyler Reddy is another one. There's 2 of us. To work on NumPy full-time. So the 2 of us are working there our managers are actually the NumPy community. There's a steering council of about 20 people who are volunteers, who are representatives of the NumPy community, people who are active in committing and reviewing pull requests. And we have someone at BIDS who's our day-to-day manager, making sure we get salaries and that we get paid. But we view it that the community is actually driving our agenda and what we're doing. I don't know if I answered your question, but I kind of described the situation. More questions? Yeah. Can I compare the experiences of working in different places? I've worked in a startup where we were 2 people, and I worked in a very large software company in the north of the country. And I'm now working on open source basically in an academic situation. I have to say that it's a lot slower and demands a lot more patience than either of the other 2 options. If you're in a large company, there's always room to push your agenda forward, and you can kind of create this. You can carve out your own little enterprise sometimes, your own little atmosphere. If you're at a startup, of course things are moving fast and you're breaking them all the time. We can't break NumPy, right? People will get very annoyed if we do a release that breaks NumPy. So we have to be very careful with every commit we do. We have to be, most large open source software projects have no idea who their end users are until they piss them off, right? Then we hear who's actually using the software. Until then, we have no idea how many, there's millions of downloads a month. We don't know where that stuff is going or who's doing what with it and what corners they're going to actually discover that we changed something. We changed the printing in between 113 and 114, changed the way that when you print an array, the way it's displayed on the screen. We got lots of issues about it, okay? People are very, very upset that now it shows 5 places after the period rather than 7, okay? So those are the kinds of things you have to deal with, and you have to be careful not to break. So you have to move very slowly, and also working with volunteers, it means, like I described before, it means that things take a long time. You need a lot of patience. Yes. More. Yes. Yeah, so we have a test suite that has about 5,000 tests in it, I think. And that's just within the NumPy test suite itself. So we use Jenkins, Circle CI, and AppVeyor to test on Linux, Windows, and we're just starting now to test on ARM v8. And then before we do a release, we do a pre-release, and we ask downstream users like SciPy, AstroPy, people we have good communication with, please try it out. They run their test suite on it and tell us if we've broken something. So it's all test-driven development. And hopefully what we try to ensure is that every time someone does a pull request, that pull request has coverage within the test suite. We run gcoverage to make sure that we're running the lines of code that we think we're running, and pull requests should always have tests with them.